For the very first time in recorded history, a vital and steady ocean pattern has completely failed. And this unexpected event might be a harbinger of much bigger changes ahead. Imagine the ocean's rhythms as a well-choreographed dance, warm air twirling with cold air, cold water flowing beneath warm water, all forming a stable, predictable cycle. This dance has guided global climates and ecosystems for decades. But this year, that rhythm was broken. And it's raising urgent questions among scientists. Since records began over 40 years ago, the Gulf of Panama has reliably experienced a seasonal upwelling each year from January through April. During this process, cold, nutrient-packed water rises from the ocean depths, pushed by the persistent northerly trade winds. This upwelling feeds marine life, cools the coastal waters, and supports vibrant coral reefs. However, in 2025, this crucial phenomenon failed entirely for the first time ever. Experts, including climate tipping point specialist Tim Lenton from the University of Exeter in the UK, are watching closely. Only time will reveal if this is a singular event or the beginning of a new worrying norm, Lenton explained. A continuation of this failure could signal a real-world climate tipping point where changes become abrupt and potentially irreversible. The surprising findings were recently published in the respected Proceedings of the National Academy of Sciences, sparking intense debate about the stability of ocean systems we once considered reliable. But what do scientists mean by tipping points? These are thresholds where a small change can trigger a drastic shift in Earth's climate systems. Think of it as a balance tipping too far, leading to sudden collapse or irreversible transformation. This idea has even inspired popular culture, such as the sci-fi movie The Day After Tomorrow, which dramatizes the collapse of a major ocean current. While Hollywood took creative liberties, the core concern is grounded in real science. Major ocean currents are vulnerable and could rapidly change as the planet warms. Though the Gulf of Panama's upwelling isn't currently listed among the classic climate tipping points, this event raises alarms for the health of coral reefs, marine ecosystems, and fishing industries relying on these waters. Lenton highlighted that whether or not this is a tipping point in itself, it contributes to another critical tipping point, the ongoing loss of coral reefs caused by dangerously warm tropical seas. Without the regular cooling effect from upwelling, reefs face even more stress. Additionally, the absence of upwelling means less nutrient-rich water reaches surface layers, threatening the food web and possibly triggering tipping points in ocean life beyond just reefs, including fisheries that many coastal communities depend on. So what exactly is this upwelling, and why does it matter so much? The Smithsonian Institution's Tropical Research Institute, leading the recent study, explains that during the dry season in Central America, roughly December to April, the persistent northern trade winds push surface water away from the coast, allowing cold, nutrient-laden water from deep within the ocean to rise to the surface. This natural process encourages the growth of plankton, the base of the marine food chain, which in turn sustains flourishing fish populations. Beyond ecology, it even keeps beach waters cool during the local dry, sunny months, the prime time for tourism. But this year's failure to see this upwelling has led to warmer coastal waters and a significant decline in local marine productivity, an unprecedented shift that could ripple through ecosystems and economies alike. Scientists are puzzled, but have a leading hypothesis. Aaron O'D, the Smithsonian's lead researcher on the project, points to unusually weak and infrequent northerly trade winds as the main culprit. Without strong winds to push the surface waters aside, the nutrient-rich depths don't rise, he said. However, OD also emphasizes that the root cause of this change in wind patterns remains unknown, and scientists need more time and data to uncover why this happened. One burning question remains. Is human-induced climate change already affecting these winds and this upwelling? Right now, the answer is unclear. Regardless, this event highlights how quickly fundamental ocean processes can be disrupted, threatening fishers' livelihoods that have relied on these rhythms for generations. Looking ahead, the research team is actively monitoring the Gulf of Panama through satellites and direct ocean measurements. A research cruise is planned for early next year to analyze subsurface waters more deeply and check whether the upwelling will return or if a new pattern has emerged. Moreover, the team has joined forces with scientists from the Max Planck Institute to combine atmospheric and oceanic data, applying sophisticated models to better predict future changes. OD hopes that this breakthrough study sparks greater interest and targeted research on these tropical systems, which were previously assumed to be reliable but are now showing signs of vulnerability. And here's the controversy. Could this failed upwelling signify the start of a domino effect on ocean ecosystems globally? Could we be underestimating how fragile these natural cycles truly are? Some may argue this is just a rare anomaly, while others see it as an ominous wake-up call that demands urgent attention. What do you think? Is nature sending us a warning we're ready to ignore, or is this just a blip on the radar? Share your thoughts below and join the conversation on this critical issue that challenges our understanding of Earth's changing climate.